Hello, Honors Algebra students. Mr. Lawrence here with your flipped lesson, and we're going to quickly review two types of graphs. One, we're going to find the domain and range after we graph it, but the first type is we're going to review graphing these linear inequalities, like y is less than 2x minus 1. Now remember that that looks like it's in slope y-intercept form, and so I'm going to find the y-intercept, which is -1. And then my slope is 2, or as a fraction, 2 over 1. And I will do like that. Okay? I know my line needs to be broken, remember, because it's not equal to, right? Okay, so I'm going to get a broken line. Okay. And then I'm going to choose my test point. And I love choosing the origin for my test point. Okay, I'm going to plug 0, 0 into my inequality. I got a false statement. I will shade the opposite side of the line. So all my shading will come down here. Okay, so there you go. That's it. Let's say another one really quick. I've got 2x minus 3y is greater than or equal to 6. This is in standard form. I'm going to find my y-intercept, which looks like it's going to be 6 over -3 or -2. My x-intercept is going to be 6 over 2, which is 3. If I wanted to find my slope, I could. I don't need to, but it'd be -2 over -3, which is +2 over 3. And watch this. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Okay. I know it's going to be a solid line because it is equal to. So I'm going to get a solid line here. 1, 2, 1, 2, 3. This should all be review up to this point. And again, I can use my origin as my test point as long as my line does not go through the origin. So I'm going to plug 0. -0 is greater than or equal to 6. That is a false statement. And again, in this one, I will not shade the origin. Okay, I'll shade the other side. And notice some of you are saying, hey, if it's less than, I shade below. Well, this is a greater than or equal to, and I shaded below. Don't rely on a little trick. Use a test point. Smartest way to do it. Okay, very good. Let's come down to problem number 3. We have an absolute value inequality, equation. And this is one where we're going to need to find the vertex, right? The vertex. Remember, I take the inverse of what's inside. What makes that negative? Or makes that 0, excuse me. And here I just take that value. So my vertex is going to occur at 3, -2. So I go 1, 2, 3, -2. There's my vertex. And then my other points I can find by using the slope. So I'm going to have a slope of 1 over 2. So I'll rise 1, run 2. Rise 1, run 2 would get me there. All right. And then on the other side, I'll rise 1 and go back 2. And then, of course, I'll rise 1 and go back 2. Okay. So my graph is going to look like this. Kind of a wider V, right? Now, I need to know what my domain and range are. And remember, the domain are the x values. They're the input. They're what x is allowed to be. Well, a good way to test for domain is to get a vertical line that is not actually part of the graph, okay, and ask myself what numbers x can be. And if I move this vertical line along here, I can see, like, can x be 0? Sure it can. Can x be 1? Can it be 2? 3? In other words, is my blue line intersecting with my black V? Yeah, it is. So therefore, x can be 3. Can x be 10? Yep. The black line and blue line intersect, don't they? Could x be -8? Well, your first thought might be that no, because they're not intersecting, but remember, this goes on forever. And look at that, they will intersect at some point. Okay, so you might be thinking that there's no x value that can't go into this equation, and you're correct. The domain for this absolute value function is all real numbers. Now, let's do the range. Let's do the range. To do the range, we're going to use a horizontal line. All right, so let me get a horizontal line out. It doesn't matter, it's a broken line. We can make it a solid line. Watch this. Okay, I've got this horizontal line. Now, I'm going to start up here at 10. Do you think this black V will intersect the horizontal line eventually? Sure, won't it intersect like over here and over here somewhere? Probably even off the screen, right? So it's going to intersect, going to intersect, going to intersect, intersecting, intersecting, intersecting. Oh, look at that. I don't think it's intersecting anymore. I don't think the black V is crossing the magenta line anywhere below this point right here, below my vertex. Hey, I was moving along the y-axis, right? The range for this problem is all real numbers such that y is greater than or equal to the y-coordinate of my vertex. Yeah, the smallest number that my y value could be is negative. Okay, so there I have my solid line, and I'm going to ask, does the black V intersect the magenta line, the horizontal magenta line? Yeah, sure it will. Won't it intersect like up here somewhere, and also up here somewhere, maybe even off the computer screen, right? So let's check this out. It looks like it's going to intersect above everywhere. Okay, still intersecting, still intersecting. I'm looking for a place where it won't intersect. Intersect. Hey, look at this. Look at this. It's not intersecting down here. See? It's intersecting on the, not intersecting below the vertex. See that? The vertex is the lowest point. The way we write that is like this. It's all real numbers such that y is greater than or equal to -2. Where did I get the -2 from? It's the y-coordinate of the vertex. Wouldn't you agree with me that, okay, this is -2, right, for the y-coordinate? This is -1. This is -1. These are 0, right? Every y-coordinate on this black line is at least -2 or greater, right? There's nothing down here. Like that's a negative, that's what would that be? 1, 2, 3, 4, 5, 6. That's -6, but there's no point on the black line that has a y-coordinate -6. All right, let's look at one more example. Okay, let's find the vertex here. All right, the vertex is going to be -5, 1, right? So I'm going to go -1, 2, 3, 4, 5, +1. Now, hopefully we've discovered now that the slope is here, but that negative means my v is going to be flipped upside down. So I'm going to go down 2 and right 1. Go down 2 and right 1. Down 2 and right 1. But because of symmetry, I'm going to go down 2 and left 1. Down 2 and left 1. Down 2 and left 1. And I think I put that 1 in the wrong place, and I'm sure Nelson will come up and tell me about that on Tuesday, but I'm going to go down 2, and there we go. So my v in this case is going to look like this. All right, it's going to go like that, and it's going to go like that. Okay, so now I got to do my domain and my range. All right, now for my domain, again, I'm going to use a vertical line, and I'm going to see, can x be a really small negative, like -1,000,000? Sure it could, because if I go out here, eventually that black line will intersect it. Eventually they'll cross if I just keep extending, extending, extending. Okay, can it be 0? Sure can. Can it be positives? Yeah, because this line, this ray is going to go forever. It's going to keep going, and eventually they will cross each other. So my domain is going to be all real numbers. Okay, let's get a horizontal line out to test for our range. There we go. There's our horizontal line. And it looks like the black V is going to intersect everywhere below 0. It's going to intersect at 0. It's going to intersect in the positives. Oops, it stopped intersecting, didn't it? What's the vertex? The vertex was at negative 5, 1, right? It looks like the range is going to be all real numbers such that y is greater than or equal to, no, not greater than or equal to, less than or equal to 1, because all these y values are below it. And there you go. That's the lesson for today, figuring out the mean and range based on an absolute value number graph, using a horizontal line and a vertical line to help us tell them. By the way, you'll be having a test coming up on Thursday of this week, all right? Good night, everybody.